All right, so today we are going to be talking about AI in robotics. So, so a large part of this session will I'll actually end up talking about video games. So that's actually kind of interesting, I would say. So you would actually find that there's a, when we talk about AI in robotics, there's actually a huge overlap between what goes on in the video game industry and what goes on in robotics, surprisingly. So yeah, let's see where this goes. So first I'll start off by giving like a video game. This is actually something that somebody wrote up. This is not like an official video game or anything. And then I'll sort of go on into like what are the differences between AI and ML, and I'll give like two broad examples. One being a behavior tree, and one being reinforcement learning. So this is actually something that I think that the two of you brought up in lesson 4, saying that you wanted me to speak more about reinforcement learning and control problems in general when I showed you the clips of the OpenAI platform. So with that, let's get started. So before that, I just want to ask you guys a question. Have you guys ever played Mario? Oh yes, okay, yeah, that's great. So you'll be able to understand. Oh, great, both of you, good, good. So you'll be able to understand the next clip that I show you. Yeah. So before playing this clip, this is like a 5-minute long clip. Let me explain what is going on. So what you're about to see is a software written by a person. His name is Seth Bling, I think. I don't know if that's his real name. So he has written a machine learning program that can basically control Mario, and it can make Mario win the game or win at least this particular level. So we'll play the clip. At the end of this session, I'll explain. Towards the end of the session, I'll explain how you can, what this algorithm is about and how you can implement this to solve OpenAI problems. Because how this is solved to play Mario and how this is solved to play OpenAI problems, the algorithms used are basically the same. Let's watch it to the end. It's only 5 minutes long, and then I'll give my commentary on it. So I hope you found the video kind of interesting. So believe it or not, the specific algorithm that this guy used right here called Neuroevolution, it was the very same algorithm that I used in my master's thesis to solve OpenAI problems. And that is the sort of reason I wanted to bring that video right up. So basically, the principles behind this algorithm and in last week's video. Uh, Sorry, in the fourth week's video, they're basically used to solve the same types of problems. So in case you guys forgot what OpenAI and reinforcement learning is, so these are a couple of examples on what OpenAI is. So once again, it's basically an open source platform for you guys, for the whole robotics and machine learning community to test out their latest machine learning algorithms. So these are all the problems that you see here, and you can see there are a bunch of games as well. So in all these problems, reinforcement learning and neuroevolution, they're basically sort of similar, but they have key distinctions, can be used to solve all these problems. So I just wanted to bring that up. So before we move further, before we talk about what reinforcement learning is, let's take things a step back and let's start from the ground up. All right. So when we talk about machine learning and AI, these are buzzwords that that are being played right now in the industry. This is what everyone wants to do. So let's understand what it's all about first. So at the core of it, machine learning and AI largely are decision-making systems. So you can see in the Mario example, so which was an application of this one particular type of machine learning, it was a decision-making system, right? So Mario had to figure out when he should jump, when he should move left, when he should move right, when he should not jump, and he did this without any human intervention. So that's essentially what machine learning and AI is at its core. But there is a key distinction. So you can see that there is an overlap between those two fields, but refers to like a family of problems which are rule-based in nature. So if you recall from my previous lesson, I told that obstacle avoidance is a rule-based algorithm. So you can define, a human can define their own rules and they can code it out and it'll probably work very well. So that's what I meant by a rules-based algorithm. So that's what you call AI in general. So machine learning is something that humans have limited, a limited say over in terms of what the agent actually does. So in machine learning, the agent actively learns from its previous or historical data to make improved decisions. So that's where machine learning and AI comes in. So first, we'll start off with a rules-based algorithm, and then we'll move on to reinforcement learning. All right. So what do I mean by a rules-based system? All right. So it's actually very simple. So the simplest example of a rules-based system is like if-else statement in programming. So you have a bunch of scenarios, and if a particular scenario is encountered, then you do a particular set of commands. So this is your simplest AI that you can actually build up. So for example, let's say we're building an obstacle avoidance robot, and we want to do it with a bunch of if-else statements. We can probably do something, and that'll also end up being decently well, to be honest. So for example, if say a particular condition is met, suppose we have obstacles to our left and to our right, what do? We go straight. And suppose we have another case. Suppose we have obstacles to our left and straight ahead, we turn right or we move back. So that's how it works. So humans write out a set of scenarios, and for each scenario, we have a set of predefined actions that the agent or the robot should do. So that's the simplest form of AI, to be honest. So this is not machine learning because there's no active learning taking place. The robot is just doing what it's technically programmed to do. But to be honest, this sort of rules-based system is very powerful. And in fact, modern robotic systems do use these techniques. So one particular example is called a behavior tree. So a behavior tree is like a more complicated rules-based system. So it's still a bunch of if-else statements, but you have some more complexity involved. So in a behavior tree, I've shown a simple behavior tree right here. You have three types of nodes. So you have a composite node, you have a decorator, and you have leaf nodes. All these green things that you see here, they are leaf nodes. So so leaf nodes are basically actions, and everything else are conditions. Everything else is a condition. So for example, let's take that obstacle avoidance scenario. So suppose we see an obstacle to our left and right. So we can it'll sort of break it down into further scenarios, and then it is further broken down into certain actions. So these actions can either be executed sequentially, or it can be executed like one or the other, like an option. So in fact, I've linked a sort of master's thesis from my colleague, and he basically built a robot from scratch, and he used like a behavior tree to do simple obstacle avoidance. So you can sort of check that out, and yeah, you can sort of see that these are very human driven in the sense that you can make up your own rules, and if it works, it works. That's really great. And you can also see that these are things used in the video game industry. So I read that games like Halo, Bioshock, they all use this to model the. Okay, so I just listed out a few examples here of a behavior tree. These were a couple of examples of a behavior tree. One was in Pac-Man. I think the link is opened up right now. Oh, videos. It's fine. Yeah. So could you guys tell me like a few disadvantages that you can think of behavior trees, knowing that it's a rules-based algorithm, and you have to constantly update rules for it to work? So can you think of some disadvantages? Yep. So Aditya says it would not be very efficient if it just uses if-else. That is very true. So yeah, I should have mentioned that it's not just if-else. So there are some more complicated behaviors like random selection of which particular type of composite node that you have to select. But essentially, you are right. You would not have too much of efficiency, and more importantly, for complex stuff, right? So for all the OpenAI problems that I showed you, you will probably need a huge decision tree to cover each and every scenario, right? Suppose we're playing this Mario instance, for instance, right? You would have to come up with a huge behavior tree to even think of covering all the bases and making sure that you pass the level. So certain rules-based algorithms will not always work. All right. So those are the sort of disadvantages of behavior trees. So you can use them for simpler tasks like obstacle avoidance. It's not too difficult. I mean, I guess you guys can think of certain rules right here. You can think of like maybe 5 rules, and you can probably have like a maze solving robot. But for more complicated challenges like in OpenAI, you would need more behaviors, and you would not want a human to write down all the behaviors and all the scenarios. So that's where machine learning comes in to effect.